Okay, so this is the 11B handout. So it's Unit 11 is based on area stuff. So all these problems are going to be mostly related to area. So let's work our way through some of these problems. So find the area of each shape below. Adjacent sides are perpendicular. So uh, basically, if it looks like a right angle, it probably is a right angle. So let's see. So that means that the first shape that we have here is a rectangle. And we know that this angle is 63. We know that the area of a rectangle is base times height. And we know that the base is 10, we just need the height. So it's 10 times whatever h is. So we need to solve for the height. Let me call that h. So if I use the 63, I know that's a right angle because it says perpendicular. The 10 is an opposite side. And this h is an adjacent side, so that's going to require a tangent. So if I do tan 63, that's going to be the opposite side 10 over the adjacent side h, and if I multiply the h over, then I get that, and then I'd have to divide both sides by tan 63. And if you plug this into a calculator, you end up with 5.093 for the height. So this is really 10 times 5.093 for the area of the rectangle. Oh, sorry, not 953. So this is a 53 up here, 953. So then we end up with 10 times that, so we just move the decimal one place, so it's 50.953 right there. So 50.953. So there's that one. This one, it's not drawn to scale because the 3s look longer to me than the 4s, but oh well. Oh, right. So in this one, let's see, we could chop it into some rectangles that look like this, which I know some people were doing we're starting this problem in class. In this case, this area is just 4 times 3, so that's 12. This length right here is 4 plus another 4, so the whole length is 8. So if I do 8 times 3, I get 24. And then this whole length, this is 8 plus another 4, so this is 12. So if I do 12 times 6, I get 72. So then the total area would just be 12 plus 24 plus 72, which ends up being 108. Is that right? 6, 8. Yeah, 108. So that's one way to do it. You could also do it in a slightly quicker way if you realize that this square, or sorry, not square, but this rectangle right here is 4 by 3, and this gap right here is 4 by 3. So you could, pretend that we haven't filled any of this in, you could chop off this rectangle and move it to here. And then really what we're solving for then is the area of this big rectangle. Whoops, sorry. Right there. Because all you do is you slide that piece in. And so then this is 4 plus 4 plus 4, so the whole length here is 12. And this is 3 plus 6, so this is 9. So 9 times 12 is 108. So you could get it that way too. Okay, let's take a look at number 2. So we've got a certain rectangle, perimeter is 140. So let's see, perimeter is the distance all the way around the rectangle. So let's draw a little rectangle here. And if the width is x, then we'd have to explain why is the length 70 minus x. So let's pretend we don't know what the length is. We'll call it y. So then x plus y, that's the distance all the way around. That's got to be 140. The goal is to show that y, the length, has to be this. So let's try to get y by itself. So first we'll simplify. 2x plus 2y equals 140. So 2y has to be 140 minus 2x. And then I'll divide by 2 and get 70 minus x. So the length has to be 70 minus x, right? Another way of thinking about it is like this. If it's 140 all the way around the rectangle, then just this part should be half of 140. It should be 70. So if this part's x, the rest of it is what's left over from 70. So 70 minus x. So that's kind of the more informal way to think about it. And then it says write out an expression for the area of the rectangle. Well, the area of the rectangle is going to be length times width or base times height, whichever you prefer. Either way, it's going to be the x times the y, which is 70 minus x. So there's an expression for the area of the rectangle. Now the next problem in part B, it says, what if the area is 1,000? Then what are the dimensions of the rectangle? So let's make the area 1,000. So we'll take this same formula and we'll say 1,000 equals x times 70 minus x. Well, I can multiply out the x term, I can distribute it and get 70x minus x squared. And let's see, let's bring all the terms over to the left side. So we get positive x squared minus 70x plus 1,000 equals 0. So then at this point, we've got an a is 1, a b is negative 70, and a c is 1,000. And we can plug this into the quadratic formula. And if you do that, we get two answers, x equals 20 or x equals 50. So let's take a look at what happens if x is 20. Right? Remember, our rectangle is x for the width and 70 minus x for the length. So if x is 20, then the length here is 70 minus x. So we end up with 20 by 50. So we know that 20 by 50 works. And if x was 50 instead, if x equaled 50, well then 70 minus x would be 20. So really, you end up either with a 20 by 50 or a 50 by 20, but that's the same rectangle, just turned sideways essentially, if you want to think of it that way. So either way, we end up with 20 by 50. Okay. So let's take a look at the other side of the page. So page 2 here. Find the area of that shaded polygon. So basically, we're going to build some slope triangles again. So let's do that. So here's one. Here's one. Here's one. And then there's one more that we can build right here. Ooh, that was kind of messy. There we go. Okay, and if we figure out the length going around, let's see, up it goes from 4 to 7, so that's 3. Across it goes from negative 5 to 1, so that's 6. 1 to 5 across is 4. From 7 to 5 down is 2. Let's see, 5 to negative 3 would be 8. 3 to 5 would be 2. If you wanted this part right here would be 4. And this part, let's see, along here, negative 1 to negative 5 is 4 across. And up from negative 3 to 4 would be 7. So generally speaking, we've got a big rectangle and we can get rid of 4 triangles around it. And if we do that, we're left with the pentagon in the middle. So I'm going to label these triangles 1, 2, 3, and 4. And so if we look at the area of triangle 1, well, that's just half base times height. And since these are right triangles, because they're slope triangles, the base and the height are the 3 and the 6. So 6 and 3 goes there, and then this ends up being 9. Area of triangle 2 is 1/2 4 times 2, which ends up being 4. Area of triangle 3 is 1/2, the base is 4, and the height is 7. So that's half of 28 is 14. Area of triangle 4 is 1/2, base is 2, height is 8. So that ends up being 8. And then if we add up all these rectangles, the sum of the rectangle, you might remember the symbol for sum, this being sum of, sorry, not rectangle, sum of the triangles ends up being 9 plus 4 plus 14 plus 8. That all ends up being 35. So we know the triangles add up to 35. The rectangle is going to be, let's see, the whole length here is 2 plus 8 or 3 plus 7. That's 10. And then this whole length is also 10. So we got a 10 by 10. That means it's 100. So if I combine these two things together, the area of the polygon is going to be the rectangle minus the triangles put together. So that ends up being 65 units squared. So we could just write 65. Number 4, let's see, diagram here. We got a decagon, so 10 sides, and explain why APB has to be exactly 36. So we've got 10 congruent chords going around here. Let's see, what can we do? Well, if we cut this up into 10 triangles, we know that all those triangles would be the same, right? So can cut the decagon into 10 congruent, I was going to say identical, but might as well say congruent triangles. And all 10 central angles put together are 360 degrees. Because if you think about it, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all the way around, and we know that all the way around is 360. So that means that each one of them, so each angle, each central angle, is going to be 360 over 10, which is 36 degrees. So therefore, measurement of APB has to be 36 degrees. Okay. So then let's take a look at number 5. 5 says, use the same diagram and suppose the radius is 20. So these guys are 20. It says, find the length of AB and the altitude of APB coming from P. So let me redraw this triangle right here, just so we have more to work with. So these are 20. This is PAB. And we know that this top angle now is 36 degrees. So in order to solve for the length of AB, I'm going to have to slice this triangle down the middle. And I'll call these guys X. And then the 36 gets cut in half because it's an isosceles cut by an altitude. So if I did, let's see, X is the opposite side, 20 is the hypotenuse, so I'm going to need sine. So sine of 18 equals X over 20. And then I'll multiply the 20 over. And X ends up being 6.1803. So AB is really 2X. So if you multiply by 2, you get 12.361 if you round to 3 decimal places. Let's see, what are the units for this? Oh, since the radius was in inches, all the lengths that we're doing are in inches. And then we need the altitude, so I'll call that Y. And we could use cosine to get Y. So cos 18 is Y over 20. So 20 cos 18 equals Y. So then Y ends up being 19.0211, or 19.021 inches. Okay, so I hope that helps a little bit, and hopefully I'll see you guys next time.